Welcome to the first session on Six Sigma Green Belt Program. The objective of this session is to first understand the basics on what is a process and how it is critical for improvements. The fundamental idea of manufacturing or production is to create something that has a useful form. This has certain tolerances that it must meet in order to be considered acceptable by the customer. The processes used is determined by a variety of factors. A quick review of process principle basics is essential before you start the journey of Six Sigma. So what is a process? Let us learn this in details in this first lesson on Six Sigma. A process is defined as a sequence of interdependent and linked procedures which at each stage consume resources like employee time, energy, machines and money and convert the inputs such as material, data and parts into outputs. Thus a process is a sequence where all activities are linked as sequential steps, mostly one at a time. The change or transformation takes place in the processes. The critical word in this definition is convert. Improvements in a processes is a key factor. Attention to the people involved in the process is essential. Now let's rearrange these words and put it more logically for understanding it better. Thus a process shall be very simply explained as input converted into outputs to achieve the goal or end result. What is this end result? For a business it is making money. Businesses are run to achieve a certain goal of success. Though we may go each day to office to reduce defects or improve production, the ultimate goal of all organizations is to create revenue. There are two types of factors that affect the output, the controllable and the non-controllable factors. The controllable factors are, for example, temperature, pressure, gas mixture, material, voltage, etc. These are within the control level of this process. Normally an operator works on these controllable factors to achieve the output. The non-controllable factors are out of reach for this operator. Output quality characteristics, also called the response, are the properties of a product or a service that are required to satisfy the customers. These are characteristics that customers expect or demand from the service. Quality characteristics or the output quality measures can also be described as variables that comprise the specification from the customer. Organization use these output quality characteristics to assess its production capability and to ensure that the specifications are met. The CTQs, or critical to quality, are customer requirements for satisfaction with your product or service. It is always good to start understanding the process from a customer's perspective. It ensures that the problem and goal are defined in terms that truly relate to customer requirements. Critical to quality, CTQ, may include the physical dimensions of height, width, depth, and weight. CTQs are translated into critical requirements through customer-defined specifications. Now let us learn what is critical in a process. CTPs are typically key process input variables such as SOP, tools, parameters, etc. Critical to process, CTP, are the key process input variables. These are the process parameters which influences other critical approaches: critical to quality, CTQ, critical to delivery, CTD, and critical to cost, CTC. Each product characteristic should have at least one process characteristic that is associated with it. The process characteristic is the feature or element of the process that affects or controls the product characteristic in question. Now let us assume a new process where a customer requirement is expected to be no between the specification limit, also called the upper and lower specification limit. The process is expected to achieve a target diameter if 3.75 mm. The tolerance in this case is plus or minus 0.03 mm. Any point that goes out of this specification limit leads to high cost to the producer, while the green zone leads to a profit. 6 products are manufactured or 6 samples are taken from the process output. The data is then represented on the scale that is shown here. All the products manufactured in this case is within the customer expectation. Thus it is assumed that the factors and affecting positively on the output quality characteristics. As more and more products are manufactured, they are continuously measured and plotted on this scale. The target for the process is the center of the specification or the customer requirement. Thus there is high tendency for the output to be concentrated in one location. Sometimes this is in the center. As the numbers increase, there is a tendency for the data to look like a bell-shaped curve, otherwise called the normal curve. Many distributions in the natural world exhibit this normal curve shape, including arrival patterns of migratory birds, manufacturing data, height of students in a class. The normal distribution is the most widely known and used of all distributions. Because the normal distribution approximates many natural phenomena so well, it has developed into a standard of reference for many problems. Coming back to the process, as long as all the data falls inside the specification limits, the producer normally does not react. But once a point goes out, then it's time for action. In this case, one of the product is out of specification. Now let us learn a few more jargon that the quality world uses. The output that the customer expects is also called the product characteristics. A product characteristic is a feature of the product that must be controlled, such as a dimension, a color, or contamination. Each product characteristic should have at least one process characteristic that is associated with it. The process characteristic is the feature or element of the process that affects or controls the product characteristic in question. The goal should be to identify, optimize and control the process characteristics so as to avoid having to inspect product characteristics. That's what process control is all about. How do you ensure the out-of-control point gets in control or is acceptable to the customer? It costs to move the out-of-control point to in control. This could be cost for reworking, cost for repair, cost for scar. The question is, who pays for this cost? An out-of-control state is actually paid by the customer, unless the company takes it and reduces its surplus or loss. This any out-of-control state leads to high cost per product. This in turn plays into the demand and based on price elasticity leads to low market share. Thus products with poor quality costs more. Consider 3 processes with same number of products produced for the same kind of characteristics. Process A has high spread while process C has low spread, process B has average spread. The process C is tall in shape and has low sigma or standard deviation. C is a better process as the spread is small compared to B, and this spread in statistical terms is called as sigma. Thus process with less sigma value has less spread. Now have a look at the controllable factors. You notice that each of the factors are further broken down into levels. For examples, machines are broken as machine 1 and 2. The employee time is broken as high and low employee time. Similarly, the inputs factors are also broken based on the different levels at which they operate. There are these two objectives for a process. The quality characteristics should be both centered as well as with low variation. If you notice in this process output, the data is not centered and the output is normal distribution is moved away from the center. Like spread, centering is another measure of a process output. The centering is also called the accuracy or closeness to the center. The objective of all processes is to ensure quality by reducing the gap between the center of the specification and the process average. The quality is also concurrently improved by reducing the spread. Thus, the role of a Six Sigma Green Belt involves moving the process from a non-optimal state to optimal state by reducing the gaps. This state is said to be both accurate and precise. The objective is to ensure the process average is centered and the process variation is minimized. In this context, it is essential to know what is the difference between accuracy and precision. Accuracy refers to the closeness of a measured value to a standard or known value, or in a process to the center of the customer's expectation. Precision refers to the closeness of two or more measurements to each other, hence how repeating it is. Here there are four options trying to hit the target in each of these cases. By consistently hitting the target, the process is termed as precise, while coming close to the target means the process is accurate. Many processes are being run at suboptimal settings, some of them for years, even though each factor has been optimized individually over time. Finding the settings that increase yield or decrease the amount of scrap and rework represent opportunities for substantial financial gain. This is one objective of the projects in Six Sigma.